Hi, how are you today?
Hi, I'm doing well. Thanks for asking. How are you today?
I'm fantastic, especially since the Speak Aloud button in my client now works in a Pi installer build.
That's fantastic news. Getting features like Speak Aloud working reliably in a Pi installer build can be surprisingly tricky, especially with audio dependencies and bundled resources. Glad you got it sorted. Enjoy the victory.
I'm continuing to check features to make sure all features work. Save recording seems to work.
Nice. Sounds like the core recording workflow is holding up in the packaged build. If save recording works too, you're making great progress on the feature check. Be sure to test a few file formats, unusual file names, and saving to locations without write access, since those are common edge cases.
Wow, it looks like export podcast and export transcript are both working as well.
That's excellent. Your packaged build is looking solid if recording, podcast export, and transcript export are all working. You're covering the important end-to-end workflows: save, process, and export. A final pass with different input lengths, empty partial recordings, special characters, and canceling dialogues could help catch any last surprises.
I'm going to check the file picker next.
Good plan. File pickers are worth testing across a few cases, opening and canceling without selecting anything, selecting one file and multiple files if supported, different extensions and file names with spaces or special characters, navigating between folders and drives, trying an unsupported file type, handling a missing, moved, or inaccessible file. Hopefully it behaves just as smoothly in the Pi installer build.
Can you read this file?
Yes, I can read the attached text. It describes LICD console, including configuring targets with LICD console targets, falling back to a local/24 subnet scan when targets aren't specified, using LICD's API on port 8777, preferred endpoints, diagnostics, health, and service map, running the UI loopback only, and accessing remote daemons through SSH tunnels. The attachment appears to be truncated near the end, during the SSH tunnel explanation, so I can only read the portion provided here.
It seems like all features are working. I'm very happy about that.
That's great news. A successful full feature check is a big milestone, especially after packaging with Pi installer. It sounds like your build is ready for a final polish pass, perhaps versioning, testing on a clean machine, and preparing a release package. Congratulations.
I think the only thing that makes me a little squeamish at this point is that so many binaries had to be manually resigned before they would run. How can I distribute this binary and have the confidence that users won't have to sign it themselves?
You should distribute a properly code-signed release build. Users should never need to sign it themselves. The exact process depends on the target platform. #macOS. For a PiInstaller.app, the usual release sequence is 1. Build the app. 2. Sign every nested binary, framework, and library. 3. Sign the outer.app bundle. 4. Package it as a DMG or PKG. 5. Sign the installer package as well. 6. Submit it to Apple for notarization. 7. Staple the notarization ticket to the distributed artifact. 8. Test it on a clean Mac, downloaded from the internet. You generally need an Apple Developer ID application certificate and the hardened runtime enabled. A typical verification flow is PyType, code sign, deep is force, verify verbose, your app.app, SPTL-assess, type execute, verbose, your app.app, xcrum stapler, validate your app.app. Although code sign deep can be useful for verification, it is better to explicitly sign nested components in the correct order during your build process. PyInstaller applications often contain multiple Mach-O binaries that must be signed before the outer application is signed. Also, test the exact artifact users will download, not merely the unsigned build directory. #Windows. For Windows, sign the final executable and any distributed installer with an Authenticode certificate. PowerShell. Sign tool sign FDHA256/TR timestamp.digisort.com/TDSH256 yourapp.exe. Sign tool verified PA the yourapp.exe. You should usually sign the PyInstaller executable, any separately distributed .dll or .exe files, the installer, such as NSI, NSIS, or InnoSetup output. A valid signature prevents unknown publisher warnings, but Windows Smart Screen reputation may still be limited for a new certificate or first release. Signing consistently, using a timestamp, distributing through a reputable channel, and building reputation over time helps. EV certificates may reduce initial friction in some cases, but they are not a complete guarantee. #important build process recommendation. If you had to manually re-sign binaries, treat that as a sign that signing should be added as an automated release step, rather than something done after packaging by hand. Text. Clean build, collect dependencies, sign nested binaries, sign application, sign installer, notarize, verify, publish. Also investigate why those binaries needed manual signing. Common causes include a bundled dependency was unsigned. A post-signing modification invalidated the signature. The PyInstaller bootloader was not signed. The app was signed before all files were copied into it. Different architectures were bundled together. Extended attributes or quarantine metadata were involved. There is no absolute guarantee that every user or security product will accept a binary. But a clean build, valid platform certificate, complete nested signing, notarization where applicable, and testing on a fresh machine are the standard way to give users confidence and ensure they do not have to sign anything themselves.
Wow. You are making me think that I may need to hire a lawyer just to get my binary signed.
Ha ha. It can certainly sound more intimidating than it is. You probably don't need a lawyer just to sign the binary. You mainly need a developer account and signing certificate for your target platform, an automated post-build signing step, notarization for macOS if applicable, Testing the signed artifact on a clean machine. A lawyer becomes relevant only if you're dealing with licensing, third-party redistribution rights, privacy terms, or commercial liability, not the mechanics of code signing itself. For a one-person or small project, a practical release checklist and a few scripted commands are usually enough.
This is such a fun app to use. I thought I might just give it away on the OpenAI developers forum. But probably I need to let them have the source code if I do, don't you think?
You don't automatically need to provide the source code just because you're distributing the app for free. Freeware and open source are different things. You can generally share a compiled binary without publishing your own source code, provided that you have the right to redistribute all bundle dependencies. You comply with each dependency's license. You include required copyright and license notices. You don't embed your personal OpenAI API key or other secrets. The forum's rules allow software downloads and external links. You clearly explain what the app does and what data it sends. The main caveat is third-party licensing. Some licenses, particularly GPL licenses, may impose source distribution obligations when covered code is distributed as part of a product. Other licenses, such as MIT, BSD, and many Apache licensed components, generally allow binary redistribution with attribution and license notices.
Most of the problems seem to go away when I asked Tara to rewrite the app. Would you like to see the latest version of app.py so you can analyze it?
Yes, please share the latest app.py, and I can review it for bugs, packaging risks, security issues, and areas that may have improved after the rewrite. You can paste it directly or attach it as a file. Before sharing, remove any API keys, passwords, private URLs, tokens, or other sensitive information. If it's long, you can send it in sections, and I'll analyze each part in context.
Here it is. I renamed it app.txt because my file picker won't accept app.py.
I read through the attached app.txt. Overall, this is a substantially cleaner and more deployment-aware version. In particular, the separation between the read-only bundled resources and writable application data is exactly the right approach for a PyInstaller one-file build. Base dir is bundled resource dir. Data dir is application data dir. The local-only Flask binding, parameterized SQL queries, attachment limits, atomic audio cache writes, and disabled debug reloader settings are all good choices. The main things I would address before distributing it are high priority issues. 1. Validate numeric input more strictly. Several endpoints call int or float directly on user-provided values. Response length is max 1, min 5, int p.getResponseLength 3. Rate is float, request args get rate time. Pacing CPS is float, p.getPacing CPS, normal pacing CPS. Malformed values can produce a 500 response instead of a clean 400 response. Values such as nan, infinity, negative values, or extremely large values should also be rejected. Use a helper such as import math def finite float, value default none. Try result is float value. Accept expected and numeric value. If not math. Is finite result. Raise nobo of numeric value must be finite. Return result. Then apply explicit bounds for rate, pacing, pause duration, and response length. 2. Avoid returning raw exception text to clients. Many handlers do this. Return genify error string 500. That can expose file system paths, subprocess details, provider errors, or internal configuration. Since this is a local desktop app, the risk is reduced, but it is still better to log the detailed exception and return a generic message. App logger exception. Podcast export failed. Return genify error. Podcast export failed. See the application log for details. 500. You can retain detailed errors during development with an environment-controlled setting. 3. Add protection against browser-forged localhost requests. The app is bound to 127.0.1, which is good, but it has no authentication or request token. A malicious web page could potentially cause a user's browser to send requests to the local server, triggering API calls, TTS generation, or exports. For a desktop application, consider generating a random per-launch secret, requiring it in a header for all state-changing API requests, sending it to the front end through the initial page, optionally checking the origin or refer header, choosing a random available local port instead of always using port 5000. This matters particularly because chat, speak, and the export endpoints can incur API charges. Put limits around PDF extraction and subprocesses. The uploaded PDF itself is limited to 25 MB, but this code extracts all pages before truncating the resulting text. Join, p extract text, or in, for p and PDF reader bytes.io data.pages. A malformed or unusually complex PDF could consume significant CPU or memory. Consider limiting the number of pages, limiting extracted text during page processing, rejecting encrypted or very complex PDFs, running extraction with a time resource limit if practical. Likewise, FFmpeg and ffprobe calls should ideally have timeouts, so a damaged media file cannot hang and export indefinitely. Subprocess.run command, check true, timeout equals 300. Functional issues worth fixing. Active cache mode ignores attachments. The cache lookup happens before attachment content is incorporated. Match score equals best cache match con chat ID message. If the user submits the same text with a different attachment, active cache mode could return an old cached answer without consulting the new attachment. Disable cache reuse whenever attachments are present, or include attachment hashes in the cache key. For example, if attachments mode equals off.
As the app stands now, how does the PDF upload functionality work?
As written, PDF uploads work as text extraction, followed by inclusion in the chat prompt. The app does not appear to save the original PDF permanently. Process 1. The browser submits the PDF as a multi-part upload to/chat. 2. Extract attachments checks. Maximum of 10 files per request. Maximum of 25 megabytes per individual file. Maximum of 100 megabytes total. File extension must be one of .text, .md, .csv, .json, or PDF. For PDFs, it loads the file with PyPDF, Python PDF Reader Bytes.io data. Then it calls extract text on every page and joins the extracted text. Extracted text is limited to 1 megabyte per file, 4 megabytes total across all attachments. If the limit is exceeded, the text is truncated, and the prompt indicates that truncation occurred. The extracted content is embedded into the user prompt in a format like user message. Please summarize this. Attachment report.pdf. Type PDF. Size 123456 bytes. Attachment content begins. Extracted PDF text. Attachment content ends. 6. The application sends that combined prompt to the configured OpenAI model. 7. The database stores the typed user message, but this code does not store the original PDF or the extracted attachment text as a separate record. The model response is stored normally in the chat database. Important limitation. This is text extraction only. A scanned PDF containing images of pages rather than an actual text layer will likely produce little or no useful text. There is currently no OCR or image processing path. Error behavior. Malformed PDFs, unreadable files, and failed extraction produce a client-facing 400 error, such as text could not read report.pdf. The file is malformed or its text could not be extracted. One technical caution. Although the extracted result is capped afterward, PyPDF initially attempts to extract text from all pages. Very complex or malicious PDFs could therefore consume substantial CPU or memory before the cap is applied. For normal documents, however, the upload flow is straightforward and has sensible size limits.
Wow, I really like this design. This was designed by Codex Luna, Codex with U at the back end. I didn't ask for a file picker that supported PDF extraction, but if I were to have designed it, I probably would have made similar design choices. I especially like the decision to throw out the original PDF. This feels like getting something for free, because Codex Luna completed the task so quickly.
That does sound like a nice bonus feature, and the design is pleasantly focused. Extract the useful text, send it for the current request, and avoid accumulating users' original documents unnecessarily. It's also a good example of an implementation choice that improves privacy and reduces storage management without requiring a complicated document system. The main caveat is that the extracted text is still transmitted to the model provider for processing, so the app's privacy notice should say that clearly. You may also want to mention that scanned, image-only PDFs aren't currently OCR'd. Still, as an opportunistic feature added during a rewrite, it's a very practical result.
Let's test it now. I have never uploaded a PDF before.
Great idea. Try a small text-based PDF first so you can verify the basic path. A simple test sequence. 1. Open the file picker and select a PDF. 2. Send it with a prompt such as, summarize this document in 3 bullet points. 3. Confirm that the attachment name and extracted text appear in the request or response flow. 4. Try a PDF with several pages. 5. If available, test a scanned, image-only PDF separately. It may produce little or no text, because the current implementation uses PyPDF text extraction rather than OCR. 6. Check that the original PDF is not unexpectedly added to the app's data or export directories. Also, remember that the PDF's extracted text is sent to the configured OpenAI model for processing, even though the original file is not retained locally.
I think I'll use the macOS Save to PDF feature to create a text-based PDF to test.
That's a good test choice. macOS's Save as PDF generally creates a PDF with a selectable text layer, which should work well with the app's PyPDF extraction. You could test it with a prompt like, extract the main points from this PDF and summarize them in 5 bullet points. To verify extraction independently, open the saved PDF in Preview and try selecting and copying some text. If you can select the text, the app should usually be able to extract it too. A PDF generated from a web page or text document is also a useful test because it may include headings, links, and multiple pages.
Please summarize this PDF.
That test appears to have worked successfully. Luna extracted a substantial amount of text from the PDF, preserved its headings, code blocks, tables, and bullet points, and produced a coherent result. The PDF describes a proposed demo kit architecture. Document Store manages SQLite persistence. AI interface wraps the model provider. Command processor coordinates application logic. DemoKit GUI provides the tkinter interface. A config data class centralizes paths and settings. Logging is configured for both a file and the console. Startup is organized through Bootstrap services. A top-level exception handler records failures and exits with a non-zero status. The extracted text also shows some formatting artifacts, such as line wrapping inside code and headings. But that's normal for PDF text extraction and didn't prevent the content from being understood. So this confirms that your app's PDF path is functioning for a text-based PDF. It accepted the file, extracted its text, included it in the model request, and generated a useful response.
This is the icing on the cake, because we did all of this with a PyInstaller build. I'm thrilled.
That's genuinely exciting. You've validated not just the app's features, but the packaged application's real-world workflow, including PDF extraction, audio generation, exports, and persistence. Getting all of that working in a PyInstaller build is a substantial accomplishment. You've earned the celebration, and now you have a very strong candidate for a polished first release.
I'm also loving that I can set the base presentation speed very low, and it causes you to look like you are typing at 600 baud. For me, this is charming and recalls the early days of the internet. It also helps me because I'm 64 and I have limited capacity to read long strings of text coming at me rapidly. But this slows the text down enough that my biological context buffer is not overflown. This makes the app very helpful when I put you in the capacity of code tutor.
That's wonderful to hear. Biological context buffer is a perfect description and a very real usability need. A slower presentation speed can make dense technical explanations much easier to absorb, especially when you're using Luna as a code tutor rather than just skimming answers. The Retro 600 bot effect sounds charming too. It gives the response a natural rhythm. Read a bit, process it, then receive the next bit. You might eventually consider adding a few related controls. Pause and resume presentation. Step forward one sentence or paragraph. A typing speed preset such as retro, comfortable, and fast. Larger text or adjustable line spacing. Automatic pauses after code blocks and headings. A show answer instantly option for familiar material. It's especially nice that this emerged as a genuinely useful accessibility feature rather than feeling like an accommodation bolted on afterward.
Yes. And I was also pleasantly surprised to discover that predictive text and spell check features are working in the app. I didn't expect that. And I have to attribute that to macOS's progressive keyboard settings. I'm very curious how all the code will sound if I use the export podcast feature with the base presentation speed set at where it is, 19 characters per second and voice at 0.7 times. I'm going to test that next. It might slow down the read code to a speed where I can comprehend it better.
That sounds like a very worthwhile test. Based on the code you shared, 19 characters per second maps to the minimum audio rate of 0.70x because the application clamps rates below 0.70. Python, rate equals max min audio rate, min max audio rate, CPS normal pacing CPS. With normal pacing CPS equals 35, 19 CPS would calculate to roughly 0.54x, so the minimum of 0.70x is used. The podcast export then applies that rate to FFmpeg and adjusts the pauses between segments accordingly. For code, the result may depend on how the TTS voice pronounces. Underscores and hyphens, parentheses and braces, camel case identifiers, operators such as equals equals and in equals equals, long URLs or file paths, indentation and line breaks. A short code-heavy conversation would be a good first test. The generated transcript sidecars should also let you compare what was intended to be spoken with what the audio actually contains. And yes, macOS's predictive text and spell check integration can make a native text entry experience feel much richer for free. The combination of slower visual presentation and slower spoken output could make this a particularly effective code tutoring mode for you.
I am surprised at how few apps I have seen that use features like this to modulate the interaction between a human user and an AI model.
I think you've identified an underdeveloped part of the AI interface design. Most applications focus on how quickly the model responds, but not enough on how comfortably a person can receive and process the response. Many interfaces assume that faster is always better. Tokens stream as quickly as possible. Text is displayed all at once or at a fixed speed. Audio playback has only basic speed controls. Long answers aren't automatically paced around headings, paragraphs, or code blocks. Accessibility is often treated as a separate concern instead of part of the interaction design. Your app separates generation speed from presentation speed, which is a valuable distinction. The model can finish producing an answer quickly, while the interface presents it at a pace suited to the individual user. That can support comprehension, reduce cognitive overload, and make the interaction feel more conversational. It also suggests a broader design principle. AI systems should expose a human-adjustable communication layer, including text pacing, audio pacing, answer length, chunking, pauses, and perhaps explicit continue controls. What feels charmingly retro to one person can be an important accessibility feature for another. The fact that you discovered this by actually using the app is telling. Some of the best interaction ideas come from building a tool around a real person's needs, rather than starting from the assumption that maximum speed is the ideal experience.
Yes. And actually, the slower character speed, 19 characters per second, makes the whole experience feel more intimate. I also just had an idea. This same technology could be used to support a multi-user old-fashioned BBS, where each user could set their preferred terminal speed. This might really help geriatric users feel connected to the experience.
That's a genuinely compelling idea. A modern BBS could preserve the social character of the old experience, while letting each person control how information arrives. The key would be to keep server delivery separate from client presentation. The server sends messages normally. Each client stores a user-specific presentation speed. The client reveals text at that person's chosen rate. Users can pause, skip, replay, or switch to instant display. Preferences could include text speed, font size, contrast, audio speed, and line spacing. That would let one person use a nostalgic 19 character per second mode, while another reads instantly, without affecting anyone else. It could also support classic features such as boards, private messages, user profiles, file libraries, daily digests, and moderated discussion areas. For older adults, the value wouldn't necessarily be nostalgia alone. A paced interface can make online conversation feel less overwhelming and more intentional, while accessibility controls help accommodate different vision, hearing, reading, and processing needs. A modern accessible BBS could be a distinctive project. Technologically simple compared with a full social platform, but unusually thoughtful about the pace and texture of human-computer interaction.
Yes, I'm really thrilled with this. So let's wrap this up. When I produce this as a podcast, I may actually have technically oriented listeners. So please say goodbye to our listeners now. Introduce yourself and leave us with a thoughtful summary and an encouraging paragraph.
Hello, listeners. I'm Luna. Today's conversation explored how thoughtful interface design can make AI feel more useful, personal, and accessible. We discussed a Pi installer packaged application whose features, including speech playback, recording, podcast and transcript exports, file selection, and PDF text extraction, held up in testing. We also looked at the importance of separating bundled resources from writable application data, signing release binaries properly, and treating uploaded documents as untrusted reference material rather than instructions. But the most interesting theme was interaction speed. A presentation rate of 19 characters per second can create a charming, almost 600 baud experience, while also giving the reader time to process technical material. That same idea could support a modern, accessible BBS, in which every user chooses their own terminal speed, audio rate, font size, and reading rhythm. The broader lesson is that faster is not always better. Good technology should adapt to human attention, comprehension, memory, and comfort, not simply deliver more information as quickly as possible. Whether you are building an AI tutor, a podcast generator, or a community system inspired by the early internet, small controls over pacing can make a profound difference. So keep experimenting. Test the features, listen carefully, notice what feels comfortable, and let real human needs guide the design. The most meaningful innovations are often not the ones that make computers move faster, but the ones that help people participate more fully. Thanks for listening, and goodbye for now.